University and not from Rosas Cantinas University in El Paso City, because I said in El Paso City, in Rosas Cantinas University, you have to go to class, they give you A anyway, and you go to class, they will give you a margarita. You know? Or when you interview for a job, and you say, I come from Texas A&M, they will listen to you. And when you say, I come from Rosas Cantinas, they will say, no, gracias. And I have brought the same thing to the students, the guys here in the University of Tennessee, and I have told the kids that you are getting a degree from the University of Tennessee, not from Rosas Cantinas University in El Paso City. I have to explain to them what it means. So I'm telling you, all of you, that you need to work hard, you know, be enthusiastic, have goodwill, you know, because you are going to get a degree from the University of Tennessee, not from Rosas Cantinas University in El Paso City. And since you are not getting the degree from Rosas, but from the University of Tennessee, then you should be happy to run the extra mile to get the recognition that comes with a degree from the University of Tennessee. Raise your hand if you understand that. Oh, thank you all. Okay. Okay, my pointer here, my clicker. So we understand this. After you do that I said, then you get that one. And now you do have an identity matrix. Now you can become really mechanical, super mechanical. Okay, but this M is going to demand some attention because you don't want to get mistakes in your math and so on. You need to be careful. Okay, and one of the things I like to do when I solve problems like this is work with fractions, even if it takes me a little bit more. Because once you start with a calculator rounding off the numbers, you don't really have it right 100%. So I encourage you to work with the fractions, even if it takes a little bit of time. And that's what I did in this example. So notice that in this, now my basic solution is R1 equals 7 and R2 equals 10. Therefore, the value of the objective function is 17m minus 17m, yeah. or here in this problem, look, minus 17m. After you do this, the multiplication of this, this is 7m, and this is 10m, then you are going to have 17m. Okay, you scan, see you will be optimal. This problem has an optimal solution. Instead of this, you have a 0 here, if you happen to have these things. Now, if you get R1 and R2 out of the basic solution, that means that R1 and R2 are non-basic, and remember, non-basic means 0. So you can have a value in the basic box and have a value and have a 0. That's possible, but most of the time we get things out and declare them non-basic, and then the non-basic variables are automatically set equal to 0. While the ones that continue to be basic, they may be equal to 0, but they have not been set equal to 0. They happen to become equal to 0. I will talk a little bit about that. At this time, don't worry too much about it, but here I have a solution that is not feasible in the context of the original problem, or in the context of the new problem, it is feasible, but not optimal. So let's see what happens here. Now we need to scan the 0 values and see which one, in your opinion, is the one that is the most negative. Remember, M is a very large number. That's right. That's the x1. Okay. Now, quickly divide. Why do I put this? I know x1 is coming in. Which one comes out? Then divide 7 by 1 and 10 by 2. I skipped that. Look at this 7 and this 10. 7 divided by 1, 10 divided by 2. Which one is better? 5 is this one. Okay, then do row operations, and I have to have a 1 instead of the 2, and 0 everywhere in that column. I did it like that. See how quick we can move? Once you know the stuff, then look, this is a 1 here, and then I have zeros here, 0 here, and 0 here. Obviously, to get the 0 here, you need to multiply the x1 row by 2 plus 3m, and those things need to be done carefully, you know, so that you get this. And now you have this, still, you have R1, see, still in the basis at the value of 2, so it's still invisible. Now, you look at the next iteration, what is the most negative value in the 0? The most negative value in the 0 is x2, look. Because you have a minus 7m over 2. This is a minus m over 2. This is minus m over 2. This is positive. So this is the one that is the one for x2, the most negative one. Then you do the ratio. 2 divided by 7 over 2. Now an interesting thing here. When you do the ratio, keep this in mind, you cannot replace anything if you are going to divide by a negative value. You saw in the graphical procedure that we have. So the ratio test is performed only in those rows where you can divide by a value that is positive. If it is 0, you cannot divide by 0. If it is negative, skip it. Doesn't make sense. So the only one that makes sense is this one. See, I gave you a bunch today in this comment. So when you do the ratio test, you are interested in replacing, you replace only if you divide positive value by positive values, skip the numbers, the rows that have a 0 or a negative value in that column. So that's the one. Now I need to multiply by 2 over 7 with this row. This becomes a 1. Okay, notice that x2 is coming in and R1 is getting out. This is good news. R1 is getting out. I got R2 out already, so what is the value for R2? 0. As soon as the value gets out, it becomes a non-basic variable, is 0. And now this one, R1 is going to become non-basic, is going to be 0. Very promising. We're going to have an optimal solution. Okay. So here, I have this converted to a 1 and modify this row and this row so that you have a 0 here and a 0 here and a 0 there. When you do that, you have this. What do you think about that solution now? What would you say? Okay, finish the sentence for me. That solution is, finish it. Optimal. That solution is optimal. See? Optimal solution, and so what does it mean? It means that x1 is equal to 45 over 7 and x2 equal to 4 over 7. Okay. How did you like this procedure? Pretty clever, huh? It's just the regular procedure with a little modification of the objective function. Pretty clever procedure. See, a simplex method is very clever, very smart procedure. You cannot outsmart the simplex method. You can trick the simplex method any way you want. The method would prove to be very smart, and it will give you the optimal solution if one exists. Okay, I want to show you the two-phase method. The two-phase method, then in this case, this is the same objective function, this is the same thing as I had before. So I create a new problem, that's phase 1. What is the new problem? The new problem is I want to minimize, I call it R0 now. R0 is the sum of R1 and R2. So that in the first phase of the two-phase method, the objective function is the sum of the artificial variables. So I minimize that subject to these constraints, and I have R1 here and R2 there. notice that I have the little small identity matrix here. 1, 0, 1 here, 0 in this constraint because there is no R1. For the other one, there is no R2 here, so it's a 0, 1. I have the 1, 0 and the 0, 1, but when I go for the simplex, I need to have the large one. So this is fine. Now, another thing is, this is a minimization problem, not a maximization problem. Because we can solve minimization problems too, without converting them into maximization problems. You can multiply by -1, a minimization problem, the objective function, and it becomes a maximization problem, and vice versa. Or you can solve them directly as they are given to you. So let's look at this one here. It's a minimization problem. I'm not going to multiply by -1. Okay, that is the initial tableau. Look, it's a minimization problem. I have all this thing here. I'm saying here R0 plus R1, excuse me, R0 is equal to R1 plus R2, so R0 minus R1 minus R2 equals 0, like that. So I have to ask the question again, do we have an identity matrix, the big one? We don't have it, okay? We don't have it, then how do you have it? Well, very easy, it's the same thing that we did before. You can add R1 and R2 together. No big M any vector anymore, no big M. The big M is kind of hard to handle, but it's not here. So you add these two together, and the sum of R1 and R2 is subtracted from the R0 row, and now you have this. Look, now you have this. Now, instead of looking for the most negative value, this is a maximization problem. In a maximization problem, you will look for a most negative value. So here, this is a minimization problem, then you look for the most positive value. It's the same thing. So you look for the most positive value. And the most positive value is for x1, the highest positive value. And then this x1 comes in. Look, x1 comes in and do the ratio test. 7 divided by 1, 10 divided by 2, 5. Then this comes in and R2 gets out. And then this is the pivot. And that should be 1. And this should be 0 and 0 with the row transformation procedure. Okay, I have it like that. Look. And I do this. Okay. How do I get on this? Well, I'm going to multiply this one by -3. So this is -3x1, 0 minus 3, everything. I multiply this by -3. And I add now this row to this one. You see what I'm doing? Look. So I get the one that I want to reduce, I put it here. Underneath, I put, since I want to get rid of 3, I need a -3, so I multiply this by -3. I put this multiplied by -3. Now I add them together, and I should have a 0 here.
How come it wasn't -17?
Hmm?
How did you get minus? I guess I misunderstood.
Which one? Here?
How did you get plus 17 instead of minus 17? If you added R1 and R2 and subtracted it from R0.
Subtracted from the first one, because this is 7 and 10 is 17. Subtracted from 0, 0 minus 17.
0 minus 17. So okay.
Yeah.
0 minus 17?
Well, it's added. We are adding, because you have a -1 here. So you are adding 7 and 10 is 17, and adding to 0 is 17.
I see now.
Thanks for the question. Okay, so
So it was added.
yeah. Okay, I got this one, and that's the one I put here. As an exercise, you can do the other one. Now, what do? If you want to have a, look, instead of this one, you want a 0. Then from this one, from the R1 row, subtract the X1 row. So it's a simple subtraction, Here, this minus this one gives you a 0. Do the subtraction in your head. See, and sometimes we can do this quickly in our head. And then you start subtracting and say, okay, this is the one that you are going to subtract. You say 0 minus 0 is 0 here. 1 minus 1, 0 here. Okay. And then you say 1 minus negative 5 halves is plus 5 halves. And you continue like that. And you get this value. Look, that's 1 minus 5 halves minus 5 halves is 1 plus 5 over 2, that's 7 halves. You have that. It's the same thing that we have done many times today. Same thing. Okay, then you look for the most negative value again, is this one. This one. That's the most negative value. Do the ratio test. The ratio test cannot be done with this one because this is negative. So it's 2 divided by this only, and this one gets out. Okay. And then after you divide by 7 over 2, and you get a 1 here for this one with x2 instead of r1. And then you have this one and this one. So again, in here, to get rid of this 7 over 2, then you have to multiply this one, the one with the 1, by minus 7 over 2 and add it together.
Dr. Garcia?
Sometimes, yes, yes.
Because it's a minimum problem, you're looking for the most positive?
Most positive value, yes. Now, I don't advise this, but once you are really good about this, you can simplify some things. For example, look, I need a 7 over 2 here. And I need to use this row. So instead of dividing by 1, and then multiplying by 7 over 2 and subtracting, I can do it directly from here. And I said, okay, look, 1 minus 0, 0, 0 minus 0, 0, 7 over 2 minus 7 over 2 is 0, 1 over 2 minus 1 over 2 is 0, and so on. 1 over 2 minus 1 over 2 is 0. 0 minus 1 is minus 1. You see how you can do it too? But try to avoid that situation when you are not sure. But you can do it quickly. Phase 2, this is the end of the story. Okay, I got this optimal solution. See, this is my optimal solution. Okay, now listen. The R1s already are equal to 0. R1 and R2. They are 0. They fulfill the purpose already. So they are gone. You can say them, tell them, adios. Adios, amigos. And so, now that I don't need them anymore, I'm going to remove this row, this column, and this column. I have explained this in detail in my reading guide, so I want you to give yourself my PowerPoint presentation until you get sick of it, and read the reading guide. And if you read the reading guide and you give yourself the PowerPoint presentation, you will be masters of this thing. I promise you again, as my name is Alberto Garcia Diaz, that you will be able to achieve that one. So here, I have this, so I'm going to get rid of R1 and R2, and I have that one. This is, this is the original problem. Okay, this is the original problem. Okay, you see that the original problem. This is the original objective function. Okay, So this is the one that we had over there. That's the row operation is this, do this. Because when you are in here, you have a problem. This is in the phase 2, and you start with this, the original objective function now. So look at what we did. We got rid of this, everything that has to do with artificial variables. We don't need R1 and R2. So you remove this, remove this column, remove this column. Again, remove the R1 column, remove the R2 column, remove the R0 row. Then you have only the X2 and X1 portion of the table, which is this one. And now go back to the original problem. And the original problem was a maximization problem. You will remember that. Now, in the two-phase method, in the first phase method, it's always minimization of the artificial variables. So here you go back to the original problem, that's the original objective function, and you ask yourself, do I have an identity matrix? The answer is no, I don't have it. Why don't? Because look, I need here, for X2, I need a 0 here, and for X1, I need a 0 here. Then what do? What would you do if you want to get 0 there? So using this one.
Multiply by
Yeah. Excuse me?
using the bottom one?
You have to use you have to get rid of this -2 and this -3. So to get rid of this -2, I subtract the bottom row multiplied by 2, because -2 I add -2 plus 2 equals 0. So you multiply this by 2 and add. What do you do for the other one? For the other one, then you multiply this by 3 and add it to this one, because then 3 minus 3 is 0. And after you do that, so in other words, you are going to multiply x2 by 3 and x1 by 2, and you are going to add it to the top one. You get this one. And here I'm telling you what I did. Look, I added to the 0 twice the x1 row plus 3 times the x2 row, and I got this solution. We are almost finished. Raise your hand if you understand that. Okay, great. Note that this solution is optimal, because this was a maximization problem. If it were not, then we would perform simplest iteration. We would continue with simplest iteration. Okay, now I'm going to finish this. I want you. I did an email from all of you. Okay, so each of you, not one email from all of you. So I need one email from each of you. Okay, and now when do you want to send my email? You want to look at the PowerPoint presentation as many times as you need to. Okay, then you are going to read the reading guide. When you feel good, you say, Professor Garcia, I feel good, I understand everything. That's the email. Okay? And then we will celebrate with you singing Mary Robbins' song.
I'm sorry.
Texas what? How's the name of the Paso City? I think it's called Paso City. Thank you. Have a good evening and a great weekend.
Which section of the reading guide? Is it section, which topic of the reading guide?
The reading guide is the same. It's called the Need for Artificial Variables. Everything that we did today. We are in topic number 3. That's number 3.
Hey, Dr. Garcia, is that email that we feel good, the homework? Is that, you said something about homework. You said, okay, you were gonna assign a homework. Is that what you just described?